Okay, this is problem number 64 from chapter 26. A charged particle with charge 1 nanocoulomb is located at the origin, and a second particle with charge QB equals to -3 nanocoulomb, which is negatively charged, is located at y equals to 1.50 meter. So for part A, you have to estimate the finite value of y for which the electric field is 0. Okay, so here you can write the given values as this. So this is QA, this is QB, and this is distance between them. So you have to convert these values into the standard SI units. So for part A, suppose y be the distance. Okay, this y be the distance at which E equals to 0. Okay, so at this distance y from the charge QA, which is at point, the distance y is at point P away from charge QA, so at which E equals to 0. So you can write this. So this E equals to E along y direction. Let's say this is in along y direction, will be 0 at distance y. Okay, so you can use this simple formula. So if the distance is y, then the distance for QB equals to y minus 150. Okay, from the distance between QB and this point P. Okay, you can plug in all the given values and you will get this type of quadratic formula. Okay, and you can further solve this using the familiar form of this to solve x, or for this case this is y. Okay, so when you take positive root, it will give you 0.59549 meter, which is physically invalid, because so the y must be greater than 1.50 meter. Okay, so it must be greater than 1.50 meter. So you can take another route. So whenever you do that, you will get this 2.05 minus 2.05 meter, which is the required value for y. Obviously the distance would be positive 2.05 meter. So which is the finite value of y for which the electric field is 0. So for part B, you have to find the value of y for which B is 0. Okay, so you can use the formula for B, which is this, for the combination of two charges. Okay, so here, so the distance y is between 0 to 1.50 meter. So you can look back to the equation number 26.9. so obviously you have to plug in all the values and you will get this simple algebraic equation. So whenever you solve that, you'll get y equals to 0.375 meter and b equals to, at which b equals to 0. So for y less than 0, let's say for negative y, you can just plug in this value and solve this. You will get y equals to 0.75 meter. So you can see there are no points at y greater than 1.5 meter for which the total potential is 0. So this is for the y that ranges from 0 to 1.5. So This is the answer, and there are no points at y greater than 1.5 meter for which the total potential is 0.